Welcome back. In this video, we're going to study the graphs of quadratic functions. And the graph of a quadratic function is a parabola. And we see parabolas in real life in places like the cross-section of car headlights or in satellite dishes. Same satellite dishes that you might have for your satellite TV or direct TV or whatever you have at your home. There are many different parabolas, but the standard or the typical parabola that we start with is the parabola y equals ax squared, or just y equals x squared, and we assume a is 1. And I call this Joe parabola because it's just the standard base parabola, and then from there to it we'll shift it up or down or right or left. But Joe parabola, a, the coefficient on x squared, is 1, and the vertex will always be at the origin. It's considered to have kind of the standard or typical width, and it will open upward. So here's an example of what Joe parabola might look like. If we put 0 in, we output 0. Okay, so we're putting 0 in for x, and we get 0 out. If we put 1 in for x and then we square it, we get 1 out. So 1 in for x, 1 in for y. If we put negative 1 in for x, then we get 1 out again. Okay? Our function f of negative 1 equals negative 1 squared. So when we input negative 1, we output positive 1. When we input 2, we output 2 squared, we output 4. When we input negative 2, we output 4 again. So we input 2, we output 4. Up there, we input negative 2, we output 4. And this will continue. If we input negative 3, we'll output 9. We input positive 3, we output 9. So we're going to be way up here somewhere. And you'll notice that these are a reflection across the y-axis. And in Joe parabola, the y-axis is our axis of symmetry. So our graph is the same to the right of the axis of symmetry as it is to the left of the axis of symmetry. So there's a picture of Joe parabola. Now we can shift Joe parabola around a little bit. So let's take a look at the function f of x equals x squared plus k. So if we add some value to x squared, this will shift our parabola up and down the y-axis. It's our vertical shift. Okay, so let's graph f of x equals x squared plus 3. We'll state the vertex as an ordered pair, give the domain and range in interval notation. So we have x, and our output is f of x. So let's go ahead, if we input 0, we output 3. So here is our shift, our vertical shift. Now our parabola, if all we've done is shifted up 3 units, should be exactly the same now as Joe, but now based 3 units higher up on the x-axis. So let's see if that plays out. So let's go ahead, we'll input 1 in for x. We output 1 squared plus 3, which is 4. So we input 1, we output 4. We input negative 1, negative 1 squared plus 3 is also 4. We input 2, and so we square 2, we get 4. That's 4 plus 3, it equals 7. So We input 2, we output 7, 3, 4, 5, 6, 7. And when we input -2, we're going to also output 7. And you can see that we have the same shape parabola, but our outputs are all just 3 units higher. So when we input 2 and -2, we had 4 for each of those, and now we had 3 higher, we got 7. And when we input -3 and 3, we got 9 before. Well, I bet you any money, when we input -3 and +3, we're going to get, instead of 9, we're going to get 12. And so that's what happens when we shift our graph up or down. So this is our shift of 3. So our vertex now, our new vertex, let's go ahead and answer our question. The vertex now is at the point 0, 3. And the domain of our function, the domain is our valid inputs. Well, we can input any x we want still. It doesn't matter. So that's still a function. And we can input any x that we want. So our domain goes from -infinity to +infinity. Our range, though, that's a little different. That's our y's, or our valid y's. So there are no valid y's here below 3. So our range, well, we're going to include 3, so I'm going to do a bracket, pardon me, in interval notation, goes from 3 all the way to +infinity. So I've answered that question. So let's take a look at our function in a different format. Now we have f of x equals x minus h quantity squared. So as it turns out, that's a perfect square trinomial. It's some quantity squared. That's going to give us a different impact here than x squared plus 3. Here, this is like x plus 0 squared plus 3. A little bit different than what we see down here. Okay, the plus 3 would be on the outside of this. So we're not going to deal with that right now. That's going to be just plus 0. A is still 1, and k, as I say here, is 0. So this is standard form, so our h here is really positive. We need to think of this as f of x equals x minus a positive h quantity squared. And this format will shift Joe parabola either left or right along the x-axis. This is our horizontal shift. So if f of x equals x minus 5 squared, think of this as x minus a plus 5. That means we're going to shift our parabola 5 units in the positive direction. It's going to shift 5 units to the right. So our parabola now, instead of being centered at the origin, will shift 5 units to the right, and now we've got Joe parabola looking something like that. That's x minus 5 quantity squared. And if f of x is x plus 4 quantity squared, we're going to do the opposite of what we see here. Here we saw minus 5 and we went to the positive direction. Well, now we see plus 4, so we're going to go to the left. We're going to go to the negative direction. This is really x minus a minus 4 squared. So we would shift Joe parabola. Now we would shift Joe 1, 2, 3, 4 units, and he would follow the same pattern that we saw before. But now we shifted him to the left. So that's x plus 4 quantity squared. So let's do this. Let's graph f of x equals x plus 4 quantity squared. Let's graph f of x equals x plus 4 quantity squared. State the vertex as an ordered pair. Graph the equation. We'll graph this. We'll find the equation of the axis of symmetry, and we'll give the domain and range and interval notation. So this is plus 0, so there's going to be no vertical shift, but we have a horizontal shift of 4 units to the left. So we could do a table of values if you want, where x and f of x, we know we've shifted this 4 units to the left because we are going to memorize that. So let's go ahead and put -4 in. Sure enough, if I put -4 in for x, I get 0 squared. So when I input -4, I output 0. So I'm 0 high. So that's perfect. Now this should follow the same pattern. If it's Joe Parabola, then if I just go 1 input to the right of -4, so if I go to -3, I should only be 1 high. So let's check that out. Let's check -3. So if I input -3, I have -3 plus 4, which is 1 squared, which is 1. So when I input -3, I'll put 1. When I input -2, -2 plus 4 is +2. 2 squared is, I get an output of 4. Which is exactly what I had before. If I input -1, -1 plus 4 is -3 squared, which is 9, which is going to be way up there. So my parabola is going to go like that. So that's Joe. And of course, this is symmetrical. So if I go 1 unit, it's symmetrical about this axis. So if I go to -5, well, that's the same thing as -3, isn't it? -5 plus 4 is -1 squared. And I get 1. And -6, well, I can just copy my reflection here, is -2 squared is 4. And you can see I've reflected about the x-coordinate of my vertex. So my vertex is at -4, 0. My axis of symmetry is x equals -4. It's always the x-coordinate of the vertex. Those are the same. The domain, well, I can input any value I want. Once again, so I can go from -infinity to +infinity. In my range, my valid y's, well, my graph has outputs only above the x-axis at this point. So this particular one has outputs, y's are from 0 to +infinity. Let's do another sample. Let's graph f of x equals x minus 2 quantity squared plus 1. Well, I've got this plus 1, that's my k. That is going to shift Joe Parabola up 1 unit. And this is x minus a +2 squared. So I'm going to shift my graph 2 units to the right. So I'm going to go 2 units to the right, and up 1. So I've shifted Joe from the origin 2 units to the right and up 1. That is really my new origin. So we should know that's going to be where my vertex is. My vertex is at 2, 1. And if I look at that, go back to my standard form is f of x equals x minus h quantity squared plus k. So my vertex is h, k. So how about that? That's going to be my vertex. The axis of symmetry, well, I know that's going to pass through the vertex. My axis of symmetry is going to be right here at x equals 2. Okay, as we saw in the last problem, we knew that our axis of symmetry was going to be the same as the x-coordinate of the vertex. The domain, all real numbers, from negative infinity to positive infinity. And my range, my outputs are only going to be above the vertex, the y-coordinate of the vertex. This parabola is still opening up, so here's the bottom part. This is the minimum point. Let's check that just to make sure. Well, let's go ahead and input some table of values if we need to. X and f of x. So let's go ahead and do an x of 3 and an x of 4 and an x of 5. So when I input 3, I get 3 minus 2 squared plus 1. So 1 squared plus 1 is 2. So when I input 3, I output 2, and that totally makes sense. I'm just one up, one more, like I've always been. I input 4. 4 minus 2 squared plus 1. That's 2 squared is 4 plus 1 is 5. But I'm just 4 higher from my original. So I go up here to 5. And let me guess, when I input 5, it's 9 plus 1 is 10. So I'm going to be way up here at 10. So there's my parabola. And I can do the exact same thing on the other side, but now I'll input numbers like 2 and 1 and 0. So when I input, no, I'm not going to input 2. That's my vertex. I'm going to input 1, 0, and negative 1. So when I input 1, I will output 2. And when I input 0, I will output 5. And now I've got the graph of my parabola. So my range, of course, is everything above. All my y's are above 1. So I'm going to include 1 and then go to positive infinity. So let's take a look and summarize what we've seen so far. If we have a parabola, quadratic, in a times x minus h quantity squared plus k, and we're going to call this complete the square form because this is a perfect square trinomial, so this is going to be complete the square form. If a is greater than 1 or positive, our parabola is going to open up. So if a is positive, we're going to have a parabola that opens up. If a is negative, our parabola will open down. If the absolute value of a is greater than 1, so if a is like 2 or 3 halves or 12 fifths or 3 or 4, any of those things, if it's greater than 1, our parabola is going to be narrower. This is a multiplier which is going to make our outputs go up faster than if A was just 1. Okay? It means we're going to double, we're going to do what's in parentheses, and then we're going to double that output. So the bigger that A is, the narrower our parabola will be. And of course, if A is a fraction less than 1, okay, so 1/2, 1/3, 8/9, that's going to make the parabola wider because we're not going to open up as quickly. We're not going to rise as fast, and we're going to rise at a slower rate than 1. Our outputs won't go up as fast. Our vertex will always be at HK, so they will use the opposite of what you see here, but that'll stay the same, HK. If we have plus H, then we're going to shift to the left, because plus H is really minus a minus, so that's plus H, and minus H is minus a positive H. If we have plus K, then we're going to shift up. If we have minus K, we'll shift down, and our axis of symmetry will always be H. It'll be the X coordinate of our vertex. So that wraps up our introduction to quadratics, and we will see you in class.